Okay guys, today we're looking at linear functions, 3-4, page 108, page 101, number 4 through 8. And when you see the word linear, you should think of straight lines, okay? Something that has a linear function is something that either grows gradually, evenly, or gets smaller gradually and evenly. So for example, how do we determine if a set of number is linear? We look at how they are growing. Like for example, to get from negative 10 to negative 14, it's negative 4. Negative 14 to negative 18 is negative 4. Negative 18 to negative 24 is negative 6. And from 6 to 10 is positive 4. 10 to 16 is positive 6. And this is positive 8. Okay, and this is an example of not linear. Okay, in order for something to be linear, you want it to be constant. Okay, constant change. Let's move on to number 6 here. Determine whether the data for each function is discrete or continuous. And I want to talk about discrete. Discrete is when you graph data that is that you cannot have a partial of something. Okay, when you graph like gallons of milk, for example, you can't have a partial gallon, right? And we graph that using a dotted line. Continuous is when you can have when you have a solid line. We call it continuous. Like for example, if you're graphing like the number of hours spent exercising versus calories, you can spend like 1.2 hours exercising and you can get the calories that you burn. Versus discrete, you can only really have whole numbers. You can't have 1.5 gallons or 1.5 gallons of milk. So 1 gallon of milk costs this, 2 gallons of milk costs that. So if you look at number 6, D equals 40 minus 15x represents the amount of money D in dollars you have left after buying a CD. Okay? So the question is the data, do you think the data is going to be discrete or it's going to be continuous? Now, this is going to be discrete because you can't buy partial CDs. Right, so it's going to be 1 CD, 2 CDs, and 3 CDs. Okay. Look at number 7. The deeper a scuba diver descends, the more pressure the diver feels. The function P equals 1 plus 0.0x represents the approximate pressure P in an atmosphere at x feet below sea level. Now, this is going to be an example of continuous. Okay. This is discrete up here. Because a scuba diver goes down, not necessarily in feet, but you can also go down like 2 feet and 6 inches or 3 feet and 4 inches. So this is an example of a continuous graph if you were to graph it. Okay, and number 6 was an example of discrete, where you can only have whole numbers.